Good morning. I am Devi Abhirami, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. Today I am going to discuss a topic in discrete mathematics with probability and hypothesis testing, and my topic is test of hypothesis in large sample using problems and solutions. In my previous video I have explained the basic concepts and the basic formula which are going to use for solve these problems. We can recall it. We discussed about the concept of hypothesis. There are two kinds of hypothesis. One is null hypothesis and another one is alternate hypothesis. And the student t-test formula is t is equal to x bar minus mu divided by s by root n. So by using those concepts we are going to solve this for large sample. They have given a case study problem. The case study problem is a global streaming platform similar to Netflix historically claims that the average daily watchers 2 minutes with the known population standard deviation, 92 minutes with the population of standard deviation of 28 minutes. After launching a new recommendation engine, the analytics team wants to verify the watch time has been changed or not. So we can use an z-test formula. This is written in a tablet form. So the claimed population is 92 minutes and the known population standard deviation is 28 minutes. Sample size is 2500 users. Sample mean is 94.6 minutes. Level of significance is 5%. So we are going to test a hypothesis test to predict whether the population mean differs from our sample mean. So to perform this z-test, we know the formula. What we have use an z-test formula which is similar to our t-test formula, that is x bar minus mu naught divided by x bar sigma by root n. Instead of s standard deviation we are replacing it as sigma. So we know all the values which are given in our problem itself, that is 94.6 minus 92 divided by 0.56. If I simplify it, I will get the answer as 4.64. In the problem itself, they have told that it has a level of significance is 5%. So the level of significance 5% is 1.96 when compared to my value, which is greater than the table value. If it is greater, then we can reject our null hypothesis and we can accept the alternate hypothesis. So my conclusion of this problem is there is a strong statistical evidence that the level of significance 5% conclude that the average daily watch time is significantly changed after launching a new recommendation engine. So the new recommendation engine has significantly increased the watch time. Okay. And the second problem is also a second case study problem. The multinational e-commerce company claims that the average of time customer spends on a mobile app is 12 minutes per session, and the standard deviation is 3.8 of a random sample is 1600. In the recent app, the sample mean is 12.45 and the standard deviation is 3.9 and the standard deviation is 3.8. By using a 5% level of significance, I am going to perform a test and we are going to tell the conclusion. So we know the hypothesis, null hypothesis and the alternate hypothesis. Null hypothesis means that the population mean should be equal to 12. Sometimes or not equal in the alternate hypothesis, and the same formula for the z formula, z is equal to x bar minus mu naught divided by s by root n, where my population mean is 12 minutes and the population standard deviation is 3.8 minutes. Sample size is 1600, sample mean is 12.45 and the significant level is 0.05. So by using these values I am going to substitute in my formula. The denominator value is called as a standard error. So standard error value is 0.095. So I am going to substitute that standard error value in my denominator of my formula. So if I solve it, I will get 12.45 minus 12 divided by 0.095. So if I solve it, I will get 4.74, which is very greater when compared to my table values 1.96. So if it is greater, then we can tell with an alternate hypothesis is accepted. That is, the null hypothesis is rejected. 5% level of significance, there is a strong statistical evidence that the average session time has significantly changed after the app update. So there is a significant change between the previous time and the after the app development. Okay. And the third case study problem is A bar B test on a shopping website. Version A consists of 1500 users, whereas version B is has 1350. That is N1 is 1500 and N2 is 1350. Average time x1 bar is equal to 4.8 and the average time x2 bar is 5.2. Standard deviation S1 is equal to 2.1 and S2 is equal to 2.3. For this type of case, I am going to test by using a two-tailed test formula. First, we have to write the given part in the form of a table format. So, the parameters are sample size, mean and the standard deviation. And my formula will differ for this because it is in two sample mean. Okay, so Z is equal to x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2. I am going to solve this by using my formula and the values are given in the problem itself. If I substitute it, I will get my answer as minus 4.83. Okay, the denominator values are calculated in the left side, right side of the PPT. So that the denominator, first denominator value is 0.00294 and the second denominator value is 0.0392. I am going to add those values. If I add and take the square root of that value, will give you the standard error of this problem. After that, I can compute that the Z value is equal to 4.83. For a two-tailed test, the 5% is also same. There is no difference between the t-test table. So, the 1.96 which is greater than the calculated value. So, we can accept our alternate hypothesis. Version B, that is version B is increases the time spent in the right tail test. This is how we have to calculate the hypothesis and we can conclude our solution. Okay, the three case studies are used here to explain about the Z test by using an hypothesis testing. Thank you.